when you look at number 5, what kind of graph is that going to be for question 5? It's the only one with an r squared. Yep, lemniscate. Good job. So, and because it's a cosine, it's going to be horizontal. So it should look something like this. All right, that's what it's going to look like. Now this here, this, if you take the square root of 4, you get 2, which is going to be the length. That's going to be your length, whatever that number is. So when you're designing your project, the longer you want your petal to extend, you would adjust that number accordingly. All right, so let's take out our calculators. Excuse me, I am so sorry. My allergies have been really bad since yesterday. All right, so take out your calculators. Now, yesterday I showed you how to change it to radians. So you want to make sure that it is still in radians. These are not in any particular order. And I will tell you that because you're taking the square root, when you type it in your calculator, because it's r squared, you have to type it in under a square root. How did you fix those numbers? Because you can't type in r squared. So we're going to type it in under a square root. So what you're going to type in your calculator is r equals the square root of, and then you're going to put 4 cosine parentheses 2, and then the first number you're going to put in is 0 for theta. See what you get. And do it for your second one. R equals 4 cosine. And you don't have to write this out naturally. I'm just showing you how you're going to type this in. So go ahead and start typing in. I think I gave you, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. You want to make sure that it is in radian mode, not degree mode. If your calculator is not in radians, you will not get the right answer. If you don't remember how to do that, you can bring up your calculator. I can show you how to do that. So go ahead and type these in. Now you will also, because it's under a square root, 2 of these will give you a domain error, which means that it doesn't have a point. So go ahead and take a few minutes. Does it say radian at the top? Let me see. Yeah, you can see at the top. It says RAD, so it's in radians.
How would I do one?
Does yours say RAD? Okay, no, yours is in degrees because it has a D there. So mode. So for your calculator, so I'm going to show you so you'll know, you have to hit the shift key and set up.
Oh, and then 4.
Option 4. So now, do you see at the very top where it has a R?
Yeah.
That means it's in radians.
Okay. Thank you.
Let's see for yours. Okay, so yours is like hers. You hit the shift key and setup.
Okay.
And then let's see, option 2. Oh no, yours is a little different. Unit angle. And then you
So
want
you
option
just-
2. And now it's in radians.
Okay.
Yeah. What did you all get for the first one? 2? Anybody get 2? All right. So that means you should be good. All right, you can compare. So 2 of them you should have an error. Who got an error for 2? Okay. So that means that they don't have a point. And you can see that the longest it goes is 2 because that's the square root of 4. So now I'm going to mark my grid. So we're going to talk about that because it's symmetrical. You really just need half, and the other half you can reflect. So I have 0, and then I have pi. I'm going to go ahead and label the ones that I put. I'm not putting pi over 3 or pi over 2 because those have an error, so we don't need that. Then I have 11 pi over 6 here. So that's a really good question. So I knew that it was I knew the shape of it. All right. And that's why I knew that it was going to be something like that. So I just tried to pick points that were in that area. Now, if that's confusing, which I do expect it to be, and honestly, at this point, I'm not spending a whole lot of time graphing this because you're going to use an online calculator. But if you get an error, just pick something else. So just pick numbers. And if it doesn't work, skip it. All right, so pi over 3, pi over 2, they don't work. 11 pi over 6 works. Pi worked. 5 pi over 6 worked. Oops, let me put these in black. 7 pi over 6. So let's go ahead and start graphing these out. So I know at 0, does everyone have the table? Because I'm going to zoom in really closely. Does everybody have these numbers copied down? All right. So I know at 0, my first point is 2. So I'm going to put that here. And then at pi over 6, I have 1.4. So here at pi over 6, I know that I'm in between the first and second ring, just about halfway, 1.4. So we're going to do the best we can. So this is what I was saying, Jasmine. Because I know it's symmetrical, I know that if it's a point here at 1.4, that it's also going to be a point right here at 1.4. So even though that's coming later, like 11 pi over 6 is later in our table, I just plot it now because I know that it's going to be right here. So I'm just going to plot it. That's half of the graph. And then we go to the other side. At pi, we're at 2. And then 5 pi over 6, we're at 1.4. And 7 pi over 6, we're at 1.4. And that is your graph. That's what it looks like. Now, tomorrow, because I don't think I'll have time today to show you the online graphing calculator. If I have time at the end of class, I'll introduce it. But we'll spend 5 or 10 minutes tomorrow, just kind of getting you familiar with how to use that calculator so you can design your project. And after you design it by choosing your 4 equations, you're going to transfer that to the board. All right, any questions about number 5, the lemniscate? All right, we're not going to graph number 6, but can someone tell me what it is? Is it a circle? Is it a lemicon? Is it a lemniscate, a spiral, or a rose? It's a lemicon. We already graphed one of these yesterday, which is why I'm not graphing it today. All right, so now let's get to the roses. Go ahead, take out your unit circle because it's a little easier. Go ahead and take it out. We haven't looked at it in a while. And we're going to talk about roses. And I'm just giving you the basics so you can design your project accordingly, so you understand how these graphs are generated. So first of all, this is a rose. Because this number is odd, that means I'm going to have 3. Now, if it were even, I would have to multiply that number by 2. The maximum value is 4. So each petal is going to go out to the 4th ring. Now, this is where we have to kind of go back to a little bit. And again, this is a little bit of like review for when you how to solve a trig equation, because you will have to do that on the test, but you won't have to graph a polar on the test. So where do we find our max values? So our max values are going to occur when cosine is 1 or -1. All right, so that's where we're going to have our maximum values. So I have cosine of 3 theta. So we're ignoring that 4 in the front. So cosine of 3 theta. Go ahead on your unit circle. Tell me, where is cosine 1? Where are the places where cosine is 1? What are my angles? 0. We're going to do it in radians, though. Cosine is +1 in only one place. And where is cosine +1? 0 and 2 pi. So 3 theta equals 0 and 3 theta equals 2 pi. So 3 theta equals 0, 3 theta equals 2 pi. So we're going to divide both of these by 3 because we got to solve for theta. And we get that we have our first max value at 0 and I'm going to just write that, and 2 pi over 3. So at these 2 places right here, our petal is going to reach the 4th ring. So I'm going to write that. So at 0, we're at 4. Let me write that in purple. Pick another color for that. Okay. So 0, we're going to hit the 4th. And then we're also going to hit it at 2 pi over 3. Now we know we're looking for 4 petals. That's only giving us 2. No, we're not looking for 4 petals, sorry. How many petals are we looking for? 3 petals. We only have 2, so we need 1 more. So now we're going to look at where is cosine -1. So I want you to look at your unit circle. Where is cosine -1? Cosine is -1 at pi. So when I divide by 3, I get that at theta equals pi over 3, that's when it's going to hit -4. Because if cosine is equal to -1, then that means that my pedal is going to hit -4. And again, I'm going through this pretty generally, because unless you are really, really good in the trig unit, you're going to be confused. And if you don't remember the trig unit, you're going to be confused. And you just have to review that for the final, how to solve the unit circle and all that stuff. All right, so let's just go down to our graph and plot these 3 points. So I'm going to put a point at 0, 4. So 0, 4 has a point. And then pi over 3, -4. So this is pi over 3. So pi over 3, -4. So I'm going backwards. So 1, 2, 3, 4. So right here, I have a point. And then 2 pi over 3, which 2 pi over 3 is right here. We are at the 4th ring. Now, I'm not going to talk about the zeros because you honestly don't need to know that for the graph. All right, I know that it's going to hit 0 in the middle. So it doesn't really matter what angles are going to put our center point there. I'm not really concerned about that. But I do want you to pick some additional points to kind of help with your sketch. So let's just do our 45-degree angles. So in our table, let's go ahead and build our table. So that's 7 pi over 4. It's kind of messy here. Let me see if I can do better. All right, so pick up your calculators. And these are all going to be the same numbers, essentially. But I want you to pick up your calculator and type in 4 cosine. Then it's going to start a parentheses. And then 3. And then type in pi over 4. And then do it again for 3 pi over 4, 5 pi over 4, and 7 pi over 4. All right, so go ahead and get those numbers. All right, so you should get the same number. So you should get, I think I got negative 2.8 for the first one, and then it's positive 2.8, and then positive 2.8, and negative 2.8. Who had that? So when I graph it, the one thing I want you to know is that these are symmetrical, okay? So let's look at that pi over 4, for example. So pi over 4 is right here. And at pi over 4, we got negative 2.8. So that means that here I have to go backwards. And 2.8 is almost at the 3rd ring. So I'm going to go back 1, 2, and then about right here. So this is where that point would be. But this is what I'm trying to get you to understand. If there is a point right here, everybody look at the screen. If there is a point right here, there's also going to be a point on this side around that same point, 2.8. Okay, so this angle is not an angle on our unit circle. This angle is somewhere between 240 and 270. So it's halfway between, so it's like, what is that, 255. That's not something we normally would graph, but we can approximately put that point there. Does that make sense what I'm trying to say here? So you can draw your petal. Even though I don't have 255 degrees as an actual angle, I can approximate it. So now let's look at the next one, 3 pi over 4. 3 pi over 4 is here. So we have 2.8, so I'm going out 1, 1, 2, and then the third ring, so about right here. Go ahead and put a point. But again, I know it's going to also follow around somewhere between 90 and 120. Halfway between 90 and 120, it's going to hit there again. So I'm just going to put it there. I'm going to approximate it. That's my third petal. And then my last one, let's see, we got 5 pi over 4. Did we already do that one? 5 pi over 4, which is right here. Okay. That one we already got. And then the 7 pi over 4. Oh, that's what I didn't. Okay, so we didn't have the points over here. We didn't put that because we would have to put in a 15 degree and we would have to put in like 365. That's not points that we normally would do, but we can still approximate it. So we know that it's going to hit about 2.8 here and here. So I just approximated it. I didn't actually plug it in my calculator, but I approximated it just to draw the sketch of the graph. And that's what the rows will look like. All right, let's do our last one and then we'll be finished with notes. Miss Bryan is done. This is it. No more notes from me. All right, last one. So we got another rose. This one, the max length is 3. Oh, that's here. How many petals? So because this is even, we have to double it. So this one is going to have 4 petals. So let's figure out where our max is going to occur. So the max is going to occur when sine, because this is a sine graph, is 1 and -1. And I know I need 4. So let's start off with where is sine equal to 1. So sine of theta, so this is sine of 2 theta, because it's 4 petals, equals 1 where? On the unit circle. So the first place is at 90, which is pi over 2. And I need 2 places, so I'm actually going to add to that 2 pi. So if you add 4 pi over 2 to that, you also get that it's going to be at 2 theta equals 5 pi over 2. Because I need 2 places. So I have to go around the unit circle twice to get 2. If I had 6 petals, I would have to go around 3 times. So the more petals, the more revolutions you have to make. Now, in order to solve this, I'm going to divide both sides by 2, which is the same thing as multiplying by 1/2. So let's go ahead and multiply both sides by 1/2, which is going to cancel this out. So I get that I have at pi over 4, because when you multiply this together, do you agree that this is pi over 4? Pi over 2 times 1/2 is pi over 4. So pi over 4, and then the max value is 3, so that's going to be a point. And then on this side, it will be 5 pi over 4. And the max value is 3. So we got 2 petals so far. So now, where is sign 0? Not 0. When is sign -1? So sine is -1. Sine of 2 theta equals -1. 3 pi over 2. And then I need to go around it again. 7 pi over 2. All right, so now I'm out of space. Hold on, I got to zoom out all the way so I can get some more space. Okay. All right, so now, oh, that does not look like a 7 pi. Let me do better. 7 pi over 2. Okay, so we're going to multiply both sides by 1/2 again. Now, these places, because this is where sine is -1, this is where my radius will be a -3. So the first place where I have a radius of -3 would be 3 pi over 4. Because when you multiply across, you get 3 pi over 4. And then the second place is 7 pi over 4. So let's go down to our graph and plot these 3 petals. So it's at the 45, so does everybody have this part down? I want to zoom in on the graph, but I don't want to zoom in until we have that written down. So I'll give you a minute to write that down, and then I'll zoom in on the graph. All right, so let's go ahead and do that. So we got pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Okay, so all of these, we're going to have the longest extension of our petal. So at pi over 4, we're at 3. And then at 5 pi over 4, I'm at 3. And then at 3 pi over 4, I'm going backwards. And then at 7 pi over 4, I go backwards. So when I'm looking at this, I just need to know, my thinking is, if I put in these two angles right here, is everybody looking at the screen? If I put in these 2 angles, I can mimic that on the other 3. So the only 2 angles, this is where I'm saying you kind of have to use your own judgment. Well, you won't have to graph these by hand, but you will have to create a table. I would just put in pi over 3 and pi over 6. Those are the only 2 I need to know, because if I know those 2, I can do all 4. So in our table, those are the only 2 that I would do. So go ahead and type those in to get your numbers. They should be the same because it's symmetrical. So whatever you get for pi over 3, you should get the same thing for pi over 6. So you're going to type in 3 sine, then it's going to be a parentheses, 2 times pi over 3. Type that in. Then you're going to do that again for the other one. So go ahead and type both of those in. And you should get the same thing. All right, so what did you all get? 2.6. All right, so that helps us, because if we know it's 2.6, I agree, that's what I got, 2.6. If I know it's 2.6, then I could just put that around around all of my petals. So here, if I know between here and here is at 2.6, I'm gonna put a point here and here and draw my petal. And then I'm gonna translate that on the other side. I'm gonna put a point here and here, because it's gonna also hit 2.6, there and there. Draw your petal. And then it's also going to hit 2.6 here and here. So you don't have to keep typing in these angles. You can, but you're always going to get 2.6. So let's not waste our time. So here and here, and we draw our angle. All right, and that is a polar. All right, so we don't really have enough time to really dig deep into our project on how to do this on the but I will show you just some basics really quickly. Hold on. The only thing I want to show you for today, for those of you who are planning to try to start thinking about your project, you need to pick your 4 graphs, and I'll tell you who your partners are in a second. But if you click on that main page where it says it says polars, it's a gray button. Here, if you click this link, that takes you to Desmos. Now, off to the side, there is a wrench. There is a wrench off to the side that makes it a polar. Because this is not polar. Would you agree that's not a polar graph? We need a circle graph, so we need to change it to a circle graph. So we're going to hit this. And then where it says grid, you're going to pick the polar graph. And it changes it to a polar, okay? And then, sorry, let me grab this real quick. You can start designing your project. So you would just type in your equations. For example, if I want to type in what we just did, you have to include R equals. So I'm going to go up here. I'm going to hit the ABCs. I don't know why that always does that. ABC. Okay, R. Is there equal there or no? Equals. And then what did we just do? What was our graph? 3 sine 2 theta. So you would hit 3. Okay. 3. That's just R equals 3. That doesn't count. We don't need that. That doesn't count as one of your 4 graphs. You have to go to functions. And there's all 6. So we're going to do a sine. And then it's 3. And you know, got to get used to it. And then ABC. You can either type the word theta, Theta, or there is a theta symbol. Oh, we didn't do 3. What did we just do? Oh, we did 2. I'm sorry. I was like, how come there's just 3 petals? Okay, let me go back. Let me do 2. So then that kind of helps you decide what it is you want, like how you want to design it. How you want to design your project. This touchscreen is kind of tricky sometimes. I'm getting better with it though. Oh, that's a spiral. Okay. Hold on. I got this, y'all. Just trying to use this thing. It's not, I need the theta to be on the inside. There we go. Okay. So you can kind of use that as a guide. So what I would recommend you do with your partner, kind of play with this, pick your 4 graphs. And then once you decide, okay, I like this graph, I like the way it looks, then you can start transferring it to the board. Yeah. No, you have to use string. Yeah, and pins. Yeah, you have to actually mimic it. And then on the back, I need a table for each one. Now, I will